The fifth and final video will be a bit long, but zip around and get help where you need it. We're going to cover a lot of ground in this one. From writing equations to solving systems of equations. A lot of these questions are going to be very quick to answer. Notice all we have to do is find the slope of each line. So using a graph, we'll count from one point on the line to another point on the line. So I notice that this is a positive slope. So we'll start with the point here, and we count up first, right? Because we're going to have change in rise, which is change in y's, over change in run, which is change in x. So m is the letter for slope. So we're going to go up 1, 2, 3, 4, 5, 6 points and over 1. That's up 6 positive to the right 1, or a slope of 6. As you begin to count, start at the leftmost point. So notice I had started from this point and I counted to this point. That is going from left to right. So again, slope is change in rise, which is change in y's over change in run. And so when I start at this leftmost point, I'm going to go down for this one because this is a negative slope. So I'm going to go down 1 and right 1, 2, 3, 4. So down negative 1 over 4. So my slope is negative 1/4. Keep in mind, as I move from left to right, if the line goes down, it's a negative slope. If the line goes up as I move from left to right, that line is positive. Next, find the slope again, but given a pair of points. And so we're going to use our slope formula, where slope is equal to the change in y's over the change in x's, and change implies subtraction. So y2 minus y1 over x2 minus x1. So the first thing we need to do is to take our coordinates here and label them. And it doesn't matter who you call x1 and y1, who you call x2 and y2, but remember that x comes first and y comes second, so x1, y1, x2, y2. Again, arbitrary, I could have called these guys x2, y2, and these guys x1, y1, doesn't matter. Now that I've had them labeled, I can carefully put them into my slope formula. y2 is the value of 8, because that was y2, minus y1, which is negative 3. So that's minus a negative 3. Then x2, 16, minus 12. Then we process. 8 minus a negative 3 is the same as 8 plus 3, which is going to be 11. And 16 minus 12 is going to be 4. So we have a slope of 11/4. Reduce the fraction if possible. 11 is prime, so that's our final answer. Now I just did the problem again. And what I did is I called the first set x2, y2, and the second set x1, y1. And so what happens is, as opposed to 8 minus a negative 3, I have negative 3 minus 8. And as opposed to 16 minus 12, I have 12 minus 16. Negative 3 minus 8 is negative 11. 12 minus 16 is negative 4. And positive over a negative is a positive 11/4. So either way, I'm going to get 11/4 for an answer. Again, just label clearly and then do your math clearly and consistently. When we have the equation written in slope-intercept form, this right here is my slope, that value in front of x. So on number 9, 9/4 is my slope. So this is just what I refer to as a point-and-shoot question, right? Find the slope. There we go. We found it. On number 14, y equals negative x. Well, this is like negative x technically plus 0, and the number in front of x is negative 1. So for this, my slope is simply negative 1. And that's it. I told you, some of these questions are just really super fast to answer. Now we're going to move into writing the equation of the line. And all you need to write an equation of a line is the slope and the y-intercept. So I can see that my y-intercept right here is at 0, negative 2. That's my y-intercept. And my slope, I'm just going to count from there to another point on the line. So up to right 1. So that's a slope of 2 over 1, or just 2. So now I say y is equal to mx plus b, where I should have numbers for m and b. Y equals, my slope is 2x plus negative 2, or y equals 2x minus 2. And that's my slope-intercept form of the equation of that line. I notice that my 2 is positive. My line moves up as I go from left to right. I notice that my y-intercept is negative, and it is. It was right there, so things look good. How about writing the slope-intercept form given the slope and the y-intercept? Again, I said all you need to write the slope-intercept form of an equation is the slope and the y-intercept. They gave you the slope of 7, so y equals 7x. They gave you the y-intercept of positive 2 plus 2. Done. Just for a little reminder, right, my positive 2 would be right here, and then up 7 would be 1, 2, 3, 4, 5, 6, 7 over 1, something like that, and that's what that line looks like, a steep positive line. That 7 indicates a steep positive line. Now this next one, using the point slope formula to write the slope intercept form, given a point and the given slope. So the point slope formula is y minus y1 equals m times x minus x1, where y1 and x1 are the points that were given to me right here. And then this is my slope. So I'm just going to substitute everybody in and do a little math. So I'm going to have y minus y1, which is negative 5. So I'm going to say negative 5 equals the slope, which was given to me as 7/2 times x minus x1, which was given as negative 2. Now this looks a little scary, but let's just tighten it up a little bit. Y minus negative 5 is the same as y plus 5. 7/2 times x minus a negative 2 is the same as x plus 2. So got rid of all the double negatives. Now I'm going to distribute that 7/2, so that's y plus 5 equals 7/2 x, no big deal. And then 7/2 times 2, the 2's cancel, that's just plus 7. Subtract 5, and for my final answer I have y equals, right, because that cancels, 7/2 x, and 7 plus negative 5, or 7 minus 5 is plus 2. And we are all set. If you went into Desmos and you entered this equation and you created a table of values, you should notice that negative 2, negative 5 is one of the values on that line, thus verifying that we are correct. We're cruising into the last few problems of the packet. Very good. Solve each system by graphing. So again, we're just graphing two lines and then looking for their intersection if there is one. So line number 1 will make the green line. My y-intercept is negative 3. So I go down to negative 3, I put a dot. Slope of 7/4, it's positive, so I'm going to go up 7 and over 4, which puts us right here. And I'm going to connect that with a nice straight line. Okay, changing colors over to blue. We're going to graph the second line. We're going to go up to positive 2. That's my y-intercept. And now using the slope, again, positive, we're going to go up 1 and right 2, up 1 and right 2. And then we're going to connect that with a nice straight line. And I notice that these lines intersect. And where do they intersect? They intersect right here. And that is at 4, 4. So 4, 4 is their point of intersection. That is the solution of this system using a method of solving by graphing. And what we're saying is that the point 4, 4 is on both lines. Next, continuing to solve each system, but this time by elimination, which means we want to make a variable go away. And if we're successful in making a variable disappear or go away, then we should be able to solve for the other variable. So elimination is one method. Another method is called linear combination. It refers to this same exact method. I'm going to take both of these. I'm going to add them together because I see that the y coefficients are the same value. They're both 4. One's positive, one's negative. So when I add these two lines together, I get negative 1x equals positive 1. I'm going to solve for the variable, isolate x by dividing by negative 1. Negative 1 divided by negative 1 is a positive 1x, and 1 divided by negative 1 is negative 1. So x is negative 1. Now we need to take that value of negative 1 and solve for y. So what I do is I put negative 1 in for x in my first equation, just because I chose the first equation. I could use either one. Negative 6 times negative 1 is positive 6 plus 4y equals negative 2. Subtract 6 from both sides because I'm trying to isolate y, and I'm going to get 4y equals negative 8. Divide by 4 on both sides, and I get y is equal to negative 2. So the solution to my system is negative 1 comma negative 2. That's my final answer. Now I want to check that answer. So what I do is I substitute both of these values, right? This is my x and this is my y, into the second equation and see if it works. Remember, this point should be on both lines, so it should be a solution to both equations, which means it should make the equation true once I substitute them in. So 5 times negative 1, which was my x value, is negative 5, minus 4, right, times negative 2 is a positive 8 equals 3. 8 minus 5, or negative 5 plus 8, is equal to 3. 3 equals 3, so this answer is good to go. Final answer, negative 1, comma, negative 2. And don't forget, you could go into Desmos and solve this by graphing to verify this. Now, we won't accept your bare answer from Desmos. We need to see all of the work, right? We need to see work. Math teachers aren't born last night, right? We know quality work from not quality work. Please do not attempt to dupe us. You're only duping yourself. We're already pretty good with the math. The second system here, it looks like the x's, the coefficients, are already ready to go. And if you add them, it should cancel out the x's. You got 8y equals 24, yada, yada, yada. And you should be able to finish this one on your own. I will tell you that it works out quite nicely. That is, there's no fractions or decimal answers. And our last solving each system is by substitution. So this would require us to isolate a variable and then substitute it into the other equation. So you'll notice that y is equal to 4x and y is equal to negative 2x. So by this theory, if we said y is equal to 4x and then y is also equal to 2x, then negative 2x, isn't this true? So couldn't I say that 4x is equal to negative 2x? Because if y is worth 2x and 4x is worth y, then aren't 4x and negative 2x the same thing? And so now I'm going to add 2x to both sides, and I'm going to get 6x is equal to 0, divide by 6, x is equal to 0. Now that we have x, we're going to say y is equal to 4 times 0, y is equal to 0. So I guess 0, 0 is our solution. And I'm going to check that in the second equation. I'm going to say 0 is equal to negative 2 times 0. 0 is equal to 0, of course. Now that one wasn't very exciting, was it? Let's try one with what we would say a little bit more meat on the bone here. I see that x is all by itself. So could I rewrite this equation and solve it in terms of x? So I say, well, x plus 4y is equal to 18. Subtract 4y from both sides. Again, this is why we need to be able to isolate variables, right? Solving equations in terms of another variable. So I solve this for x. Now, wherever I see x in the second equation, I can substitute everything that x is worth. So 3 times x minus y equals negative 24. Again, I took the first equation, solved it in terms of x. Then I'm going to take all of that stuff that x is worth and put it into the second equation in parentheses, 18 minus 4y. Now I'm going to solve for y because this only has y in it. So 3 times 18 is going to give me 54, minus 3 times negative 4 is negative 12y, minus y equals negative 24. Now I'm going to combine like terms here. So that's 54 minus 13y is equal to negative 24. Now we're on the home stretch. I'm going to subtract 54 from both sides. And the reason I'm subtracting 54 is because the 54 is positive, and the opposite of positive 54 is negative 54. Do not be confused about this negative sign. That has to do with the 13, not the 54. Okay, so we're going to drop that down. We're going to get negative 13y is equal to negative 78. Divide by negative 13 on both sides because that's the opposite of the multiplication holding them together. And I'm going to get a y of 6. Now that I have my y of 6, I'm going to go back up into my first equation and I'm going to say x plus 4 times y, which is 6, is equal to 18. X plus 24 is equal to 18. Subtract 24 because the positive is referring to the 24, and I subtract from both sides, I get x is equal to negative 6. So we have a final answer of negative 6, 6. Notice the first negative 6 refers to the x, and the second positive 6 refers to the y. Don't reverse them just because you found the y first. Now let's check our answer. Now notice I'm going into the second equation to check my answer of negative 6, 6. And the reason for doing that is I use the first equation to solve. So if I'm going to use the first one to solve for the second variable, I'm going to use this one to check my answer. So I have 3 times negative 6 minus 6 that's technically 4 negative 6's, which is negative 24. But anyway, 3 times negative 6 is negative 18, minus 6 is negative 24 indeed. So just bringing the negative 24 on the right side for the ride. Good to go. One last thing. In just under a minute, I was able to actually put this into Desmos, snap a picture, crop it into this video. So just as a student, just putting it into Desmos and checking your answer is just, it's so simple. It's a no-brainer. There's my negative 6 verification, and there were my original equations, as you can see. And that's that. So hopefully these helped you complete your summer packet and that you've done good, solid, earnest work. This will help you to be successful this year in geometry. See you soon.